Hello, my name is Marcia Spink, and I'm the Associate Director for Policy and Science in the Air Protection Division of EPA Region 3. This is Clean Air Act 101 Module 2, and it's about mobile source controls and strategies. This training module is brought to you by the Office of Transportation and Air Quality and the Office of Air Quality Planning and Standards. You will find the requirements for vehicles, fuels, in Subchapter 2 of the Clean Air Act and Title 2 of the 1990 Clean Air Act amendments. Now, this part of the Clean Air Act is almost entirely implemented by EPA. Given the movement of vehicles and the network of fuel pipelines across the country, the regulation of vehicles and equipment, emission standards, and fuels is done almost entirely at the federal level. EPA's Motor Vehicle Testing Laboratory is located in Ann Arbor, Michigan. Now we're going to talk about Section 209 of the Clean Air Act, which is regarding state vehicle and engine standards. This section of the Clean Air Act specifies what states may require and what states are prohibited from requiring of new motor vehicles and engines and non-road vehicles and engines. There are provisions for granting waivers of these prohibitions to the state of California. Such waivers require EPA to go through notice and comment. If California is granted a waiver, Sections 177 and 209E allow other states to promulgate standards identical to California. In no event may any state standards be less stringent than the otherwise applicable federal standards. I'm going to go over a brief history of vehicle emissions and controls. Now, the next series of slides provides to you the milestones in vehicle emissions control technology. I do want to point out that these technologies actually precede the 1970 Clean Air Act, because in 1964, California required control systems on model years 1966 and after cars. Rather than have me read each of these milestones to you, I advise you to read them, and you can take a look as time went on between the 1960s and the present, what kind of vehicle emission control technologies came to be required. I think what's particularly interesting to note is how the federal requirements on fuels and vehicles can help states achieve the National Ambient Air Quality Standards. Because despite our successes, air pollution remains a public health problem. A new vehicle today is up to 95% cleaner than a new vehicle in 1970. By 2020, mobile sources are still projected to account for up to 50% of the NOx emissions and substantial hydrocarbons and particulate matter emissions. Even with control strategies in the pipeline, mobile sources will continue to significantly contribute to air pollution problems in many parts of the country. EPA is continually evaluating the potential for new mobile source measures for both vehicles and fuels that could help states as they work to achieve the new National Ambient Air Quality Standard. This chart is projected 2020 mobile source contributions for select cities. It's presented for NOx, hydrocarbons, and PM 2.5. Where do emissions come from in cars? You have crankcase losses, refueling losses, evaporative emissions, and exhaust emissions. Let's talk a little bit about refueling and vapor recovery. Now, when we talk about vapor recovery, even when your gas tank appears empty, it's not really empty. There are vapors in it. And there was a time when, as you filled your gas tank, those vapors came out into the atmosphere. Now, Stage 2 controls are actually on gasoline pumps, and they're currently required in serious and above ozone non-attainment areas and in the ozone transport region. Now, what this equipment does is it actually traps the vapors and returns them to the underground storage tank. After consultation with DOT on safety issues, in 1996, EPA promulgated the requirements for onboard refueling vapor recovery controls. This is an onboard canister that will trap those vapor emissions and return them to your gas tank. When this technology is found to be in widespread use, the Stage 2 would no longer be required pursuant to the terms of the definition of what constitutes widespread use. Now we're going to have an overview of EPA's passenger vehicle standards programs. Again, we have something called the Tier 1 emission standards, and here's the background. In 1990, Clean Air Act required EPA to promulgate new emission standards for model year 1994 and newer model year passenger cars and trucks. It was phased in between 94 and 96, and compliance was based on each manufacturer's sales. The useful life for vehicles was extended from 50,000 to 100,000 miles with separate interim and full useful life emission standards. Next, we have the Tier 2 emission standards, background and review. The milestones first combined the use of gasoline formulation control and engine standards control for light-duty trucks and cars, using all fuel types. A different phase in timetable was for cars, trucks, and fuel. By 2009, vehicles were required to be 77 to 95% cleaner than Tier 1. Gasoline sulfur fuel content was capped at 30 parts per million beginning in 2006. Some of the benefits that have come out of the Tier 2 program: fleet turnover for full phase-in estimated by 2030 would reduce NOx emissions by 74%. 2 million tons per year by 2020 and 3 million tons per year by 2030. When fully implemented, it would be the equivalent of taking 164 million cars off the road. By 2030, it'll prevent 4,300 deaths and more than 10,000 cases of chronic bronchitis and tens of thousands of respiratory ailments per year. Now, the cost of the industry to comply was $5.3 billion, with environmental and health benefits of $25.2 billion. Now a little bit about EPA's clean diesel standards. Diesel trucks and buses emit 28% of the total NOx and 20% of the total particulate matter in our country. Diesel has been implicated in increased risk of lung cancer and respiratory disease. US EPA labels diesel exhaust as a likely human carcinogen. Particulate matter and NOx contribute to asthma and other cardiorespiratory health problems. Let's take a look at the benefits that will come from the heavy-duty diesel highway rule. These are the PM benefits over time. You can see they're dramatic and they're amazingly cost-effective for the health and environmental benefits achieved. These are the benefits in reducing NOx over time from the same rule. Additional benefits. Compliance costs are estimated at between $1,200 and $1,900 per engine. The cost will be between 4 and 5 cents per gallon, but that'll be partially offset by a maintenance savings of 1 cent per gallon. The total costs are estimated to be $4.3 billion a year. Let's take a look at the health benefits. The program will prevent annually over 8,300 premature deaths, over 750,000 respiratory illnesses. It'll prevent the loss of 1.5 million workdays and 2.6 million tons of NOx, 110,000 tons of PM, and 17,000 tons of toxic pollutants will be removed. The benefits are estimated to be $70.3 billion a year. Now let me go back to the costs. The costs, $4.3 billion. Benefits, $70.3 billion. What we do to control air pollution from motor vehicles and fuels is amazingly cost effective. Let's talk a little bit about non-road emission standards and fuels. Now by non-road, we're talking about engines that you don't find on the highway. Non-road vehicles and equipment. Here are the engine categories: diesel boats and ships, gasoline boats and personal watercraft. Non-road diesel program also covers farm, construction, and mining equipment. We have forklifts, generators, and compressors, lawn and garden equipment, locomotives, snowmobiles, dirt bikes, and ATVs. Yes, we're everywhere. Milestones in non-road engine standards. In 1994, we had the non-road engine rule that regulated non-road diesel engines used in non-road construction, agricultural, and other applications for the first time. In 1995, the non-road engine rule was promulgated that regulated small spark ignition engines, such as found in lawnmowers, for the first time. In 1997, we had a locomotive rule that set emission standards for nitrogen oxides, hydrocarbons, carbon monoxide, particulate matter, and smoke for newly manufactured and remanufactured diesel-powered locomotives and locomotive engines. Additional milestones in non-road engines. In 1998, the Tier 2 and 3 non-road diesel rule sets emission standards for new non-road diesel engines. In 1999, the commercial marine diesel rule reduces nitrogen oxides and particulate matter emissions from new large marine diesel engines. In 2002, large spark ignition engines in recreational vehicles were regulated for the first time. In 2003, ocean-going vessels were regulated by the Ocean-Going Vessel Rule. And in 2004, we had the Clean Air Non-Road Diesel Rule. Additional milestones and benefits were that the Clean Air Non-Road Diesel Rule reduced emissions by over 90% from non-road diesel equipment and dramatically reduces sulfur by 99% from current levels in non-road diesel starting in 2007. This step will apply to most non-road diesel fuel in 2010 and to fuel used in locomotives and marine vessels in 2012. Locomotive and marine diesel standards require the same technologies as on-highway and non-road diesel engines. It reduces PM by 90% and NOx by 80% for newly built locomotives and marine diesel engines. It tightens standards for existing locomotives and large marine diesel engines when they are remanufactured. New engine standards were phased in beginning in 2009. Now, you have the non-road heavy-duty diesel rule, or Tier 4. This is analogous to the 2007 heavy-duty diesel highway rule in that standards and diesel fuel sulfur controls work in combination. To meet emission standards, engine makers are to rely upon advanced emission controls similar to those used to meet the heavy-duty diesel highway rule. Exhaust emissions will decrease by more than 90%. This will be phased in between 2008 and 2014. Non-road diesel accounts for 47% of diesel PM emissions and 25% of NOx emissions from mobile sources nationwide. The off-road diesel sulfur limit of 15 parts per million kicked in October of 2007. This represents a 99% reduction from the 3,000 part per million baseline. By 2030, this rule will annually prevent 12,000 premature deaths, 8,900 hospitalizations, 1 million workdays lost, 15,000 heart attacks, 6,000 asthma emergency room visits, 280,000 respiratory cases in children. The health benefits of this rule are estimated to be $80 billion per year at a cost to comply of $2 billion a year. Now, we regulate aircraft separately. The Aircraft Engines Rule amends standards for NOx emissions from new aircraft and new aircraft engines beginning in 2005. It applies to new commercial aircraft, including small regional jets, single-aisle aircraft, twin-aisle aircraft, 747s, and larger aircraft. Now let's talk a little bit about the legacy fleet. Now, when we say the legacy fleet, we're talking about those diesel engines and vehicles that are still on the road that are so old that they are not subject to our new standards. There are about 11 million existing high-polluting diesel engines not subject to our new standards. So we needed to focus on how to address the emissions from the legacy fleet. And we focused on key sectors: school buses, marine ports, construction, agriculture, and freight. We promoted retrofitting, early replacement, and idle reduction. Now, we did this through local programs working with states, local agencies, and the private sector. In fiscal year 2008, national grants funded 14,000 retrofits, which reduced NOx emissions by 46,000 tons and PM emissions by 2,200 tons. To further address the legacy fleet, EPA, in consultation with its state and local partners, have come up with a national clean diesel campaign. The program activities include technology verification, technical and policy analysis, and states, local governments formed coalitions to do education and outreach. Innovative funding for projects included federal grants, loans, and tax incentives. Let's talk a little bit about what has happened with regard to clean diesel funding to address the legacy fleet. In fiscal year 2008, $49.2 million was awarded in grants for these types of projects. By fiscal year 2009, under the Resource and Recovery Act, there was $300 million awarded. This money funded 160 grants. Some of the preliminary projected results include the retrofit or replacement of 33,000 engines, vehicles, and vessels, a reduction of 5,000 tons of PM, 120,000 tons of NOx, 850,000 tons of CO2, with a health benefit of between $1.2 and $2.8 billion. Fiscal years 2009 and 2010 saw $120 million awarded in May through July of those years. We received almost 400 applications for this money, requesting in total about $600 million. And those entities that applied for these grants offered matching funds of over $1 billion. Now we're going to talk a little bit about the Clean Air Act's gasoline regulatory programs. This is a quick overview of the Clean Air Act fuel formulation programs. This first slide covers the pre-1990 programs, and you can check out the lead phase down and the volatility controls. This next slide covers the programs that were put in place as a result of the 1990 Clean Air Act and the 1995 Energy Policy Act. We're going to talk a little bit about the renewable fuel standards impacts and benefits. Now, by renewable fuels, I'm talking about basically the fuels that, for example, ethanol made from corn, but in other words, they're fuels that are not entirely petroleum-based. So as a result of the renewable fuel standards, petroleum consumption is expected to be reduced by 2 to 3.9 billion gallons by 2012. Most of this otherwise used for transportation. Carbon dioxide reductions of 13.1 million metric tons, and carbon monoxide vehicle emissions will be reduced by about 0.9 to 2.5%. Benzene is going to be reduced by 1.8% to 4%. But we have some impacts. The combined VOC and NOx increases are expected to be from 41,000 to 83,000 tons per year. It'll vary by region. Now, we don't really expect the emission increases for areas that are already using ethanol, but new areas will see this type of an increase as indicated. Gas production costs to produce renewable fuels are expected to increase for between half and 1.1 cents per gallon. The excise tax credit for ethanol will offset costs for a savings of between 0.4 to 0.7 cents per gallon. Now a little bit about Section 211, the regulation of fuels under the Clean Air Act. This section of the Clean Air Act provides EPA the authority to regulate motor vehicle fuels and fuel additives, including non-road. It provides EPA the authority to prohibit the sale of motor vehicle fuels and fuel additives except under certain circumstances. It prohibits states or any part of a state from requiring a fuel or fuel additive that differs from what EPA has determined necessary. There is, however, something called a Section 211C waiver. States may request and EPA may grant waivers to allow the sale of a fuel different than the otherwise required federal fuel. For example, we've granted waivers in a number of places for them to be able to require low RVP gasoline. EPA must conduct rulemaking to grant such a waiver under 211C. In order to get a 211C waiver, states must demonstrate that the fuel is a necessary requirement of a SIP to attain the NAAQS and that no other measure would bring more timely attainment. I do need to mention that the 2005 Energy Policy Act further limits EPA's ability to approve state fuel rules that differ from the otherwise applicable federal fuel. Let's talk about some of the success stories from the Clean Air Act's fuel program. Fuel composition changes have provided great air quality benefits. Oxyfuels were so successful, many cities were finally able to attain and maintain the NAAQS for carbon monoxide, and they often kept the program as a contingency measure in the maintenance plan. Reformulated gasoline phase 1 and 2 achieved more benefits in practice than the Clean Air Act requires. Low sulfur diesel fuel blazed the way for cleaner diesel vehicles and equipment. Low sulfur gasoline allowed for cleaner light-duty standards. And state boutique fuels allowed for low-cost, state-adopted programs where reformulated gasoline could not be adopted. Now we're going to talk about air toxics from mobile sources. So how much do mobile sources contribute to air toxics emissions? This slide is from the 1999 National Air Toxics Inventory, and it doesn't include diesel PM. But you can see the contributions from both the non-road and highway mobile emissions. This is the projected national emissions of selected mobile air toxics over time. Now you can see the reductions that we're expected to achieve as a result of Tier 2 and the heavy-duty diesel 2007 highway controls. In 2001, EPA promulgated the Mobile Source Air Toxics Rule, MSAT. Under 202 of the Clean Air Act, EPA had to set standards to control hazardous pollutants from motor vehicles, motor vehicle fuels, or both. EPA published this rule under its authority in March of 2001 that established air toxics emissions performance standards for gasoline refiners and committed to additional rulemaking to evaluate the need for and a feasibility of additional controls. And that led to the promulgation in February of 2007 of Round 2 of MSAT. This MSAT was revised to significantly lower emissions of benzene and the other air toxics in 3 ways: by lowering benzene content in gasoline, by reducing exhaust emissions from passenger vehicles operated at cold temperatures, and by reducing emissions that evaporate from and permeate through portable fuel containers. And we're going to talk about inspection and maintenance programs. You can't talk about mobile sources under the Clean Air Act without talking about the tailpipe program. Probably one of the more controversial aspects because it's one of the programs under the Clean Air Act that affected individual citizens. This is the program that said you got to go get your car tested and get that sticker. Inspection and maintenance. Now I want to make it clear that actually, the I&M programs are required under Title I of the Clean Air Act because an I&M program is a required element of a Part D SIP for certain non-attainment areas. States required to have I&M programs had to adopt them and submit them to EPA for approval into their SIPs. The original 1970s I&M tests were designed for the old technology cars where idle tests were representative. But these tests didn't check for evaporative emissions. What we mean by an idle test is that the car is brought into the inspection station, the probe is put in the tailpipe, and the car is idled. However, after model year 1981, cars will use computers to adjust the fuel mix over a full range of operating modes. What this brought into place in the 1990 Clean Air Act were the I&M programs that involved putting the car on a treadmill called a dynamometer. Now, idle testing was still used in places, but it was less representative of the emissions of 1981 and newer model year cars because of the technology change in the cars. Model years 1996 and after are equipped with advanced onboard diagnostics, OBD, for easier repairs at lower thresholds. And there has to be an OBD check for 1996 model years and newer cars. Given the substantial penetration of OBD-equipped vehicles into the fleet, most I&M programs will meet their program requirements by OBD testing, and we will no longer require the traditional I&M programs. What I've provided on this slide is resources for state and local agencies. These are the folks at EPA and on our websites where you can get information related to Title II and to programs and requirements for motor vehicles and fuels. This concludes Module 2 of Clean Air Act 101.